We're going to start a new section now called acceleration. We defined velocity here about a week ago as the rate of change of position. Velocity can remain constant or it can change. If the velocity changes, then we have what's called an acceleration. Specifically, though, we're going to define acceleration not just as velocity that's changing, but we're going to define it as the rate of change of velocity. So it's not just like, hey, velocity is increasing or velocity is decreasing, there's an acceleration. We're saying how quickly is the velocity increasing or how quickly is it decreasing. That's the acceleration, the rate at which the velocity changes, the rate at which the velocity increases or decreases. I may get in my car, put my foot on the accelerator and speed up to 100 kilometers per hour, but take a minute to do it. You may get in your car, put your foot further down on the accelerator, and speed up to 100 kilometers per hour in 10 seconds. Our speed is exactly the same, but your acceleration was higher because the rate at which you sped up was bigger. Does that make sense? That's how we're quantifying acceleration. Not just the velocity or even the change in velocity, but how quickly you're getting to 100 kilometers per hour or 50 kilometers per hour or whatever the case may be. It's the rate of change of velocity. Now, the main equation for acceleration is A is equal to delta V over delta T. Anything that's a rate has delta T on the bottom. Velocity was the rate of change of position. It had time on the bottom. Acceleration is the rate of change of velocity. It has T on the bottom. Anything that's a rate has time on the bottom. Now, velocity was the rate of change of position, so we put change in position on the top, or displacement. Acceleration is the rate of change of velocity, so we put change in velocity on the top, or delta V over delta T. What units do you think we'd use for acceleration here? What units do you think we'd use here? Jacob? Yeah, the units for velocity or change in velocity are meters per second. For time, it's seconds. So we'd say meters per second over seconds. So we would change that to meters per second squared. You could leave it like this if you really wanted to, but we usually don't. This is exactly the same thing as saying meters per second squared. So that's the way I'll always write it down. But if you wrote down meters per second, that would also work. Jacob?
Why is acceleration a vector?
Just wait 1 second here on that, okay? Does that make sense? All right. Is time a vector or a scalar? Time's a scalar, right? Time doesn't go right or left. Okay, time doesn't have any direction in the typical sense of direction associated with it. Is delta V a vector or a scalar? It's a vector, yeah. When you have a vector divided by a scalar, you get a vector. Okay? If change in velocity is a vector, then the acceleration has to be a vector as well, which means there is a direction associated with it. That direction will be the same as the direction of delta V. So if your change in velocity is to the right, then your acceleration will also be to the right. If I drop this board marker, my change in velocity is downward, then my acceleration would be downward in the same direction as the change in velocity. Now, we just went from one equation to two. We now have double the equations that we had 5 minutes ago. Just wait, because there's more coming. There are other equations that are valid in the same situation as this one. We're going to have to write down some givens in order to look at which equation fits a particular problem the best. Let's write down our other equations right now, and then we'll deal with that. We said A is equal to delta V over delta T, but we can also say that delta D is equal to VI, V initial, times T, plus 1/2 A T squared. What does delta D stand for? Displacement. VI stands for initial velocity. T stands for time. A stands for acceleration in meters per second squared. By the way, we always got to go with our standard units now. Meters, seconds, meters per second. You can't use kilometers per hour anymore. You got to use those standard units now. We also have another one that looks remarkably like this one. Delta D is equal to VFT minus 1/2 AT squared. The only difference here is that we have VF instead of VI and we have negative instead of positive. What's the VF stand for? The final velocity, yeah. We have another one, D is equal to VI plus VF over 2 times T, VI initial velocity, VF final velocity, delta D displacement, T time. And we have one more. So we're going from one equation 10 minutes ago, V equals delta D over delta T, to 6 equations now. The last one is VF squared is equal to VI squared plus 2AD. In this last equation, tell me what A stands for in this last equation. Yep, acceleration, good. Tell me what delta D stands for in this last equation. Displacement, good. Tell me what VF stands for in this last equation. What does VF stand for? Velocity final? No. Anybody want to take another stab at that? Kind of a trick, sorry, Parker. What is it? Yeah, it's the final speed. Notice there's no vector sign over it, so it's final speed, not final velocity. Good. Now, all 5 of these equations are valid in the same situations. What we're going to see over the next couple of days is a whole gamut of problems that all involve acceleration. All 5 of these equations are valid for all of those problems. We've just got to pick which equation fits the best. It's a little bit harder now. When we did velocity, there was only one equation that fit a particular problem. Now there's 5 equations that fit a particular problem, and we got to pick which one fits the best. Now, I want you to take a look at your data sheet before we go any further here, okay? Everybody take a look at the data sheet that I gave you on the first day. It looks like this. Up at the top under kinematics, you now have all of those equations. What I'd like you to do, please, is take that first equation that says V is equal to delta D over delta T. I want you to circle it, and I want you to label it as Group A. Label it as Group A. There's only one member of this group, and it's V is equal to delta D over delta T. And underneath Group A, label it as constant or average velocity. Whenever you have a problem involving constant or average velocity, we're going to use that equation, just as we did for the past week. That doesn't change. We're not saying what you did 2 days ago was wrong. We're saying now we can do more than we did 2 days ago. If you get a problem like you got 2 days ago, we're still going to solve it the same way, using V is equal to delta D over delta T. Now what I'd like you to do is circle the other 5 on your data sheet, and beside those ones, that big circle, label it as Group B. And Group B, I want you to label as acceleration. Whenever a problem involves speeding up or slowing down, you're allowed to use any of those Group B equations. You just got to see which one fits the best. Notice this one doesn't even have acceleration in it. Doesn't matter. Doesn't matter. It's valid when the object is speeding up or slowing down. All right, let's do an example. This is from your textbook, page 47, chapter 1. We know which chapter of the textbook we're dealing with because example 1.12 would be chapter 1. Example 5.14 would be chapter 5. So you know which chapter to download from Google Classroom. This one says a hybrid car. You guys know what a hybrid car is, right? It's gas/electric. Okay, when you're driving under the power of gasoline, it charges a battery, and then sometimes it uses the battery to power an electric motor as opposed to the gasoline motor. So when you're starting at a stop sign, that's the hardest on your gasoline engine, right? It uses the most gasoline. When you're starting from rest, it'll use the electric motor so that it's not burning so much gasoline getting you moving. So we have a hybrid car with an initial velocity of 10 meters per second, accelerates at 3 meters per second squared to the east. How long is it going to take this car to acquire a final velocity of 25 meters per second east? Before I do anything, before we do anything here, I want to identify whether it's a group A or a group B problem. So let's ask myself, is it accelerating? What's the answer to that question, yes or no?
Yes.
Yes, it's accelerating. It's not going at a constant velocity. It's speeding up. It's going from 10 to 25 meters per second. It's speeding up. So is this group A or group B? This is group B. That means that those 5 equations that I just learned a few minutes ago are the equations that are valid here. I'm not going to worry about which one to use right now. Now I'm going to write down my givens. I'm going to define, by the way, east as positive. What is this 10 meters per second thing? Is that A, acceleration? Is that V, velocity? Is that VI, initial velocity? VF, final velocity? Is it T, time? What is it there? Josh, what is it? Yeah, good. It's the initial velocity, VI, is 10 meters per second to the east. East is positive, so we'll just leave it as a positive value. I got something here that's 25 meters per second as well. What's that? Is that A, V, VI, VF, delta T? What is it? VF. It's VF. It's the final velocity of this car. 3.0 meters per second squared. What is that? Is it A, VI, VF, T? Jacob? That's A, the acceleration. That's the rate at which it's speeding up. What are we looking for here? Yep. We're looking for time. So let's say delta T is the question mark. Everybody needs to write down every step, okay, including the example that I'm doing right now. Okay, like, do not sit there and not write this down. If you want to write it down after I'm done, because you're just watching right now, that's okay. Okay, it's okay if you're not writing at the moment, but everybody's got to have this written done before we move on to the next thing. And when you're solving problems yourself, same deal. Write everything down, every step along the way, including the givens that we've written down here. All right, you identify that this is a group B problem. Take a look at your data sheet where you circled our group B equations, those 5 group B equations. Which one looks like it fits this equation, this data the best? William, what do you say?
VI plus VF divided by 2.
Okay, so D is equal to VI plus VF over 2 times T. Is that the one you meant, William?
Yes.
Okay, good. That is a perfectly valid equation. I'm glad you said that one. That's not the one that I would have picked, but that doesn't mean it's wrong. It is an absolutely correct equation. The problem with this one is that I don't know what T is, and I don't know what D is. So I've got 2 unknowns. Does that make sense?
Yeah.
That's a problem. That's a problem because I can't solve for one without the other. That's okay. If you write down a group B equation, a valid equation, and it doesn't work for you, William, the worst that's going to happen is you're going to not get an answer because you have 2 unknowns, right? You're not going to get the wrong answer here.
I just look for VF and VI.
Yep. And fair enough, right? Fair enough. It's the first time we've done it. Okay? Like 2 months from now, you're going to do that every once in a while, right? And that's okay. As long as you don't write down V equals delta D over delta T, that's a big problem because that's not valid for this situation. This is valid. The worst that's going to happen is you're going to get no answer. The best that's going to happen is you're going to get the right answer. You will not get the wrong answer with it. You're either going to get no answer or you're going to get the right answer. Okay? This one's a no answer one, right? Because it's got two unknowns. So let's try another one. Guys, listen, I'm perfectly fine with you guys writing down the equation that doesn't work, as long as it's valid. Okay, there's no shame in that at all. Ben, what are we going to do here? VF squared is equal to VI squared? Okay, let's try that. VF squared is equal to VI squared plus 2AD. How many people think that's a valid equation for this problem? I do. I think it's a valid equation for this problem. I don't think there's anything wrong with spotting that and trying to use that. Let's just now see if it'll fit. Okay? We know what VF is. Good. We know what VI is. Good. We know what A is. Good. Solve for delta T. But wait a second. It's not what we're looking for, right? Yeah. That's okay. Okay? Are you going to get the wrong answer this way? No. You're just going to solve for the wrong thing. Right? So you just have to try something else, right? So we've identified two valid equations that will not get me, assuming I don't make some mistake, that will not get me the wrong answer. They just don't get me the right answer. That's all. Okay, let's try another one from our list of Group B equations here. What other one do you want to try, Jacob?
I think I would use A equals V over T.
A is equal to delta V over delta T?
Yeah, sorry. But then I would manipulate it to solve for T.
That's exactly what we got to do. We rearranged V is equal to delta D over delta T. Now we're going to have to rearrange A is equal to delta V over delta T. Why? Well, look at this. I know what A is. I know what, well, I don't know what VF, delta V is, but I know what VF and VI are. So that's the same thing almost, right? I don't know what T is. Good. This is going to get me what I want. But now I got to rearrange it to solve for T. T's on the bottom. You got to get it to the top. How do you get it to the top? V divided by T, how do I get it to the top? Multiply. So it becomes A times T equals delta V. Now it's not by itself. Now I got to get rid of the A. A is multiplied by T, so how do I get rid of it? Divide. So I'm going to say T is equal to delta V over A. Does that make sense what I've done there? Okay, let's sub in my numbers now. Delta V is VF minus VI. That's 25 meters per second minus 10 meters per second, final minus initial velocity. A is 3.0 meters per second squared. 25 minus 10 is 15 meters per second. Divided by 3.0 meters per second squared ends up giving me 5.00 seconds. And we're done. This was the perfect example. Okay, it was almost like I set it up for the two people that volunteered equations here that we didn't end up using. It is perfectly okay this time and every other time to try the equations that they tried. You will never get the wrong answer. It's okay to try it. Okay, what you got to realize in physics is that success will come for you when you're not afraid to try something. When you're not afraid to try. If you sit back there and say, I'm not sure which one to use, I'm not going to try, then you're going to fail. If you try one, that's valid, that is. You don't want to try something that's like V equals delta D over delta T that's not valid, but try something that's valid. What's the worst that happens? It doesn't work out. Try something else. Okay, that's what's going to lead you to success here. All right. If you're good with that, then I'd like you to take a look at the two practice problems on page 47 of your textbook.